Good morning. In our last class, we were solving MCQs on relationship between electric field and electric potential. I have told you electric potential can be expressed as function of position. V can be expressed in terms of X. When electric potential is given as function of distance or position, you can always determine electric field using the formula E is equals to minus dV divided by dx. This equation can be used only when potential is a function of x coordinate of the position. Potential is function of x coordinate of position. If potential is a function of x and y coordinates, or if potential is function of x, y, and z coordinates of position, you have to make use of the relationship E is equals to minus dou v by dou x into I cap plus dou v by dou y into j cap plus dou v by dou z into k cap with the negative sign. This negative sign should not be left out. Minus into dou v by dou x into I cap will be minus dou v by dou x into I cap. Minus into plus will be minus dou v by dou y into j cap. Minus into plus again minus dou v by dou z into k cap. This equation is to be used when position coordinates given are x, y, and z. Right? So we have solved this problem in the last class. Here is another problem on potential and electric field, relationship between electric potential and electric field, where potential is given as function of x and y. V is equals to 4x plus 3y and putare. You are asked to find the magnitude of electric field intensity at point 2, 1, 1. You have to find out magnitude of electric field intensity at the point 2, 1, 1. So we know the relationship between electric field and electric potential when two coordinates are given. It will be E is equals to minus dou v by dou x into I cap minus dou v by dou y into j cap minus dou by dou x into V is known to us. V is 4x plus 3y into I cap is to be written as it is minus dou V is 4x plus 3y by dy into j cap. Differentiation of 4x with respect to x is 4 with this minus sign, minus 4 I cap ಆಗ್ತದೆ. Differentiation of 3y with respect to x will be 0 ಆಗ್ಬಿಟ್ಬಿಡ್ರಿ minus differentiation of 4x with respect to y will be 0. Minus into plus is minus. Differentiation of 3y with respect to y will be 3 into j cap, minus 3 j cap I. This is electric field. Now electric field is expressed in vector form. It is of the form A vector is equal to AX I cap plus AY j cap plus AZ k cap. This is in vector form. We have to find out magnitude of this vector. See, they have asked us to find the magnitude of electric field intensity. Magnitude of a vector is given by square root of AX square plus AY square plus AZ square. If A vector is equal to AX I cap plus AY j cap plus AZ k cap, then magnitude of vector is given by square root of AX square plus AY square plus AZ square. So if E vector is equal to minus 4 I cap minus 3 j cap, then magnitude of E vector is square root of minus 4 square plus minus 3 whole square. Minus 4 whole square is 16 and minus 3 whole square is 9. So 16 plus 9 is 25 with square root. 25 square root of 25 is 5 Newton per coulomb. So this is the formula for calculating magnitude of a vector. If you are asked to find out magnitude of a vector, then use the formula square root of AX square plus AY square plus AZ square. So this is how problems with respect to electric field and electric potential are to be solved. Go through the problems on potential energy of system of 2 charges and potential energy of system of 3 charges. We have seen the equations for potential energy of system of 2 charges in absence of external electric field, potential energy of system of 2 charges in presence of external electric field, potential energy of system of 3 charges is also seen. Go through this problem. A charge Q1 is equals to 5 into 10 power minus 8 coulomb is kept at 3 centimeter from a charge Q2 is equals to minus 2 into 10 to the power of minus 8 coulomb. Two charges Q1 and Q2 are separated by distance of 3 centimeter. Q1 is 5 into 10 power minus 8 coulomb and Q2 is minus 2 into 10 to the power of minus 8 coulomb. You are supposed to find out the potential energy of system of this charge. You have to find out the potential energy of this system of charges. So we have a system of two charges separated by distance of 3 centimeters. Here it is not specified that these two charges are placed in external electric field. External electric field negative anta specify madilla. So you have to assume that there is no external electric field present here. So you have to calculate this potential energy of system of two charges in absence of external electric field. ಅವ್ರೇನು ಕೊಟ್ಟಿಲ್ಲ ಅಂತಂದ್ರೆ ಎಕ್ಸ್ಟರ್ನಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಲ್ಲ ಅಂತ ಅರ್ಥ. ಎಕ್ಸ್ಟರ್ನಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇದ್ರೆ ದೇ ಸ್ಪೆಸಿಫೈಡ್. ಓಕೆ, ಸೊ ದ ಆಪ್ಷನ್ಸ್ ಆರ್ 3 into 10 power minus 4 joule, minus 3 into 10 power minus 4 joule, 9 into 10 power 16 joule, and minus 9 into 10 power 16 joule. See, I have told you potential energy of a system of charges may be positive, potential energy of system of charges may be negative, potential energy of system of charges may even be zero. You know that potential energy of system of two charges is given by U is equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R. If R is equals to infinity, that is if distance between two charges is infinity, tell me what will be the potential energy of that system. If the distance between two charges Q1 and Q2 is infinite, what will be the potential energy of that system of charges? Zero. Potential energy of system of charges may be zero, potential energy of system of charges may be positive, or potential energy of system of charges may even be negative, right? So potential energy of the given system of charges will be U is equals to 1 by 4 pi epsilon naught Q1 Q2 by R. We know that 1 by 4 pi epsilon naught is 9 into 10 to the power of 9. Q1 is 5 into 10 power minus 8 coulomb. Q2 is minus 2 into 10 power minus 8 coulomb. See, you need to substitute or you need to take into account the sign of the charge also while calculating potential energies. Potential problems ಮಾಡಬೇಕಾದ್ರೆ you must take into account the sign of the charge also. Potential being a scalar quantity, they obey ordinary laws of algebra, right? So you need to take into account the sign of the charge. Electric field, electric force ಮಾಡಬೇಕಾದ್ರೆ they are vector quantities. ಅಲ್ಲಿ ನಮಗೆ direction indication ಇರ್ತದೆ. So sign of the charge doesn't become that important. Vectors ಮಾಡಬೇಕಾದ್ರೆ. So 5 into 10 power minus 8, Q2 is minus 2 into 10 power minus 8 divided by distance between the charges was given as 3 centimeter. 3 centimeter under 3 into 10 power minus 2 meter. Centi is 10 power minus 2. 3 ones are 3 3s are 9 cancel ಆಗ್ತದೆ. 3 5s are 15. 15 2s are 30 with minus sign. Minus 30 into 10 power 9. 10 power minus 8 into 10 power minus 8 is 10 power minus 16. Minus 16 plus 9 is minus 16 plus 9 is minus 7. Minus 7 plus 2. 10 power minus 2 and goes numerator becomes plus 2. Minus 7 plus 2 is minus 5. So this will be minus 30 into 10 power minus 5 joules. Even now options that becomes 3 into 10 to the power of minus 4 joule. One decimal in the shift madri, it becomes 3 into 10 to the power of minus 4 joules. This will be the potential energy of system of two charges. Negative sign indicates that negative sign will indicate mark potential energy negative bandade antandre it means that you have to do work in separating these two charges. ಈ ಎರಡು ಚಾರ್ಜ್ ನ ನಾವು ಸಪರೇಟ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ we will have to do external work. We'll have to do external work because they are unlike charges, so there will be force of attraction between them. In order to separate them or in order to move them apart, we have to do work. Or it also indicates that the charges form a bound system. Negative sign also, negative potential energy indicates that the charges form a bound system. See, Q1 is positive and Q2 is negative, so they both must be attracting each other. They are bound together by electric force of attraction, right? Negative potential energy means that the two charges form a bound system. Can you tell me what will be the potential energy? What will be the potential energy of a nucleus and an electron? What will be the potential energy of system of nucleus and electron? Positive or negative or potential energy of nucleus and an electron separated by some distance. Whether it will be positive or negative. Potential energy of nucleus and an electron must be negative. Potential energy of nucleus and an electron. Nucleus is positively charged and electron is negatively charged. We know that electrons are bound to the nucleus. In order to remove an electron from an atom, we need to supply some energy to it. That is what we have studied in photoelectric effect. Some minimum amount of energy is to be supplied to that metal surface in order to eject electron out of the metal surface. ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಅವಾಗ ಹೊರಗೆ ಬಂದಿರ್ತದೆ because of room temperature. So negative potential energy means that the charges form a bound system. So this is regarding the problem on potential energy of system of two charges. Potential energy calculate madri andru ide formula use madri. Also, if you are asked to calculate what is the minimum work required to separate these two charges, you have to use the same formula. Work done is nothing but potential energy. That is potential energy of system of two charges. We also have potential energy of system of three charges. Potential energy of system of three charges. Nalu problem ade. We have a problem on it. Three charges, 1 into 10 power minus 8 coulomb, 2 into 10 power minus 8 coulomb, and 3 into 10 power minus 8 coulomb are placed at x is equals to 1 centimeter, x is equals to 2 centimeter, and x is equals to 3 centimeter respectively on x-axis from the origin. Origin in the x is equals to 1 centimeter hatra one charge ittare, x is equals to 2 centimeter hatra ಒಂದು, x is equals to 3 centimeter hatra ಒಂದು charge ittare. The charges placed at respective positions are 1 into 10 power minus 8 coulomb, 2 into 10 power minus 8 coulomb, and 3 into 10 power minus 8 coulomb. We need to find the potential energy of this system of charges. This system of charges, the potential energy madbeku. Options given are 7.9 into 10 power minus 2 joule, 8.55 into 10 power minus 4 joule, 6.5 10 power minus 7 joule, and 0. See, potential energy of system of three charges is given by U is equals to 1 by 4 epsilon naught, Q1 Q2 by R12, Q2 Q3 by R23, Q3 Q1 by R13, Q1 Q2 by R12, Q2 Q3 by R23, and Q1 Q3 divided by R13. Now derivation ಮಾಡಬೇಕಾದ್ರೆ ಈ ರೀತಿ triangular arrangement ಮಾಡಿರ್ತೀವಿ. For finding out potential energy of system of three charges, we'll have a triangular arrangement of charges like this. ನಮಗೆ ಯಾವಾಗಲೂ system of three charges ಬಂದಾಗ triangular arrangement ಇರಬೇಕು ಅಂತ ಏನಿಲ್ಲ. The charges may even be placed collinear. They may be placed on a same straight line. ಇಲ್ಲಿರೋದು ಹಾಗೆ ಅದ, collinear charges ಅವೆ. Three charges, 1 into 10 power minus 8 coulomb, 2 into 10 power minus 8 coulomb, and 3 into 10 power minus 8 coulomb are placed at x is equals to 1 centimeter, x is equals to 2 centimeter, and x is equals to 3 centimeter respectively. And they are placed on same straight line. You are supposed to find out potential energy of system of charges. ಈ Q1 Q2 ಗೊತ್ತಾಗ್ತವೆ. ಈ ಡಿಸ್ಟೆನ್ಸ್ ಏನಂತಂದ್ರೆ Q1 Q2 ಕೆಳಗಡೆ ಇರೋ ಡಿಸ್ಟೆನ್ಸ್, Q1 ಮತ್ತೆ Q2 ಮಧ್ಯ ಇರೋ ಡಿಸ್ಟೆನ್ಸ್. R12 is distance between Q1 and Q2. R23 is distance between Q2 and Q3. R13 is distance between Q1 and Q3. ಹಾಗಾದ್ರೆ here I have shown the representation of three charges on straight line. This is origin. From the origin, the first charge Q1 is at a distance of 1 centimeter. Second charge Q2 is at a distance of 2 centimeter from the origin. Third charge is at a distance of 3 centimeter from the origin. Hagadre, what will be the potential energy of the system of charges? Andre, it will be U is equals to 1 by 4 pi epsilon naught. Q1 Q2 divided by distance between Q1 and Q2 is AB. Q1 Q2 divided by AB. Can you tell me what will be the value of AB? What is distance between Q1 and Q2? Tell me the value of AB. AB value extra Z. Tell me the value of AB. Q1 Q2 divided by AB antade. What is the value of AB? What is the value of AB? Q1 Q2 divided by AB ಅಂತಂದ್ರೆ A ಮತ್ತೆ B ಮಧ್ಯ ಇರೋ distance. The distance between A and B. The distance between A and B is 1 centimeter. Next, Q2 Q3 divided by BC. Q2 Q3 divided by BC. We know BC is also 1 centimeter. B in the C distance ಮತ್ತೆ 1 centimeter. Next, Q1 Q3 divided by AC. Q1 Q3 divided by AC. Q1 ಮತ್ತೆ Q3 ಮಧ್ಯ ಇರೋ distance AC. And that will be equal to 2 centimeter. Q1 Q2 divided by 1 centimeter. Q2 Q3 divided by 1 centimeter. Q1 Q3 divided by 2 centimeter ಬರ್ತದೆ. AC will be 2 centimeter. Centimeter should be expressed in meter. 2 into 10 power minus 2. 1 into 10 power minus 2. 1 into 10 power minus 2 substitute ಮಾಡಿ evaluate ಮಾಡಬೇಕು. ಇದಿಷ್ಟು evaluate ಮಾಡ್ರಿ, you will get 8.55 into 10 power minus 4 joules. Try working it out. ಇದನ್ನು ವರ್ಕೌಟ್ ಮಾಡ್ರಿ ನೀವೇ. Just work it out. Okay. ಇವಿಷ್ಟು ಪ್ರಾಬ್ಲಮ್ಸ್ ಕ್ಲಿಯರ್ ಇದ್ರಾಗ ಯಾವ್ದಾದ್ರು ಡೌಟ್ ಅದ? Have any doubts with respect to problems on potential energy of system of 2 charges, potential energy of system of 3 charges, and how to find out electric field when potential is expressed as function of position? When potential is expressed as function of position, how to find out electric field intensity? Magnitude find out ಮಾಡೋದು ಹೆಂಗೆ ಅಂತ ಹೇಳ್ಕೊತೀನಿ. Electric field in terms of unit vectors find out ಮಾಡೋದು ಕೂಡ ಇಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಅದ. ಎರಡು ರೀತಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬರಬಹುದು, ಎರಡನ್ನೂ ಇಲ್ಲಿ ತಗೊಂಡಿನಿ ನಾನು. Taken both the type of problems. ಇವೆಲ್ಲ ನಿಮ್ಮ material ನಾಗವೆ. All these problems are in your material. Is this clear? If it is clear, we'll take up next type of problems. ಇದ್ರಾಗ ಏನಾದ್ರು doubt ಅದ? Have any doubts with respect to this? ನೀವು ಒಂದು ಸರ್ತಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಮಾಡಬೇಕು. You again open this material, go through the problems, solve the problems on your own, go through the formula, how or which formula is made use to solve the problem. That becomes important. Okay. So after this, you need to understand one important concept while evaluating work done to move charge from one point to another point. ಒಂದು ಪಾಯಿಂಟ್ ಇಂದ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ಗೆ ಚಾರ್ಜ್ ನ ಮೂವ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ವಿಲ್ ಹ್ಯಾವ್ ಟು ಡೂ ವರ್ಕ್. ಇಫ್ ಯು ಆರ್ ಮೂವಿಂಗ್ ಚಾರ್ಜ್ ಫ್ರಮ್ ಒನ್ ಪಾಯಿಂಟ್ ಟು ಅನದರ್ ಪಾಯಿಂಟ್ ಇನ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್, ಇಫ್ ಯು ಆರ್ ಮೂವಿಂಗ್ ಚಾರ್ಜ್ ಫ್ರಮ್ ಒನ್ ಪಾಯಿಂಟ್ ಟು ಅನದರ್ ಪಾಯಿಂಟ್ ಇನ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್, ವಿಲ್ ಹ್ಯಾವ್ ಟು ಡೂ ವರ್ಕ್ ಅಗೇನ್ಸ್ಟ್ ದಟ್ ಎಲೆಕ್ಟ್ರಿಕ್. ರಿಮೆಂಬರ್, ದಿಸ್ ವರ್ಕ್ ಡನ್ in moving charge from one point to another point in the electric field is independent of the path followed by the charge. ನೀವು A ಇಂದ B ಗೆ ಚಾರ್ಜ್ ನ ತಗೊಂಡು ಹೋಗಬೇಕು ಅಂತ ಅನ್ಕೊಂಡ್ರಿ. You want to move a charge from point A to point B. The work done in moving the charge from point A to point B is independent of the path in which you take the charge. A ಇಂದ B ಗೆ ನೀವು ಚಾರ್ಜ್ ನ ಹ್ಯಾಕ್ ತಗೊಂಡು ಹೋಗ್ತೀರಿ ಅನ್ನೋದ್ರ ಮೇಲೆ ವರ್ಕ್ ಡನ್ ಡಿಪೆಂಡ್ ಆಗಿರಲ್ಲ. You can take the charge from A to B along straight line. ಇಲ್ಲಿ work done 10 joule ಇದ್ರೆ, if you take the charge from A to B along some other path, the work done will still be 10 joules. If you take charge from A to B in some other path, the work done will be still 10 joules. Work done in moving a charge from one point to another point in the electric field is independent of the path followed by the particle, or independent of path followed by the charge. Work done in moving charge from one point to another point just depends upon initial and the final position. ಯಾವ ಪಾಯಿಂಟ್ ಇಂದ ಯಾವ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ನ ತಗೊಂಡು ಹೋದ್ರಿ ಅಷ್ಟ್ರ ಮೇಲೆ ಅಷ್ಟೇ ವರ್ಕ್ ಡನ್ ಡಿಪೆಂಡ್ ಆಗಿರ್ತದೆ. ಎ ಇಂದ ಬಿ ತಗೊಂಡು ಹೋದ್ರಲ್ಲ, ಓಕೆ ಸಾಕು. ಎ ಇಂದ ಬಿ ಚಾರ್ಜ್ ನ ಹ್ಯಾಕ್ ತಗೊಂಡು ಹೋದ್ರಿ ಬೇಕಾಗಿಲ್ಲ ನಮಗೆ. ವರ್ಕ್ ಡನ್ ಡಸಂಟ್ ಡಿಪೆಂಡ್ ಅಪಾನ್ ದ ಪಾತ್ ಫಾಲೋಡ್ ಬೈ ದ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್. ಇನ್ಸ್ಟೆಡ್ ವರ್ಕ್ ಡನ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದ ಇನಿಷಿಯಲ್ ಅಂಡ್ ದ ಫೈನಲ್ ಪೊಸಿಷನ್ಸ್ ಆಫ್ ದ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್. That is what is represented here. ಇಲ್ಲಿ ನೋಡ್ರಿ, I have represented 2 points A and B. This is point A and this is point B. I have represented 2 points A and B. Here is a charge Q. The charge Q has to be moved from A to B. I have 3 possible paths. I can take the charge from A to B along path 1. I can take the charge from A to B along second path. I can take the charge Q from A to B along this third path. ಹಾಗಾದ್ರೆ ಯಾವ ಪಾತ್ ನಾಗೆ ವರ್ಕ್ ಡನ್ ಜಾಸ್ತಿ ಇರ್ತದೆ ಹೇಳ್ರಿ? In which path the work done will be greater? In which path the work done in moving the charge will be greater? ಯಾವ ಪಾತ್ ನಾಗ ವರ್ಕ್ ಡನ್ ಜಾಸ್ತಿ ಮಾಡಬೇಕು? In the third path we have to do more amount of work. In the third path we have to do more amount of work ಅಂತ ಹೇಳಿ. But that's not true. Work done is independent of the path followed. ನೀವು ಚಾರ್ಜ್ ನ ಯಾವ ಪಾತ್ ನಾಗಾದ್ರೂ ತಗೊಂಡು ಹೋಗ್ರಿ, the work done will be the same because in all 3 paths the charge is moved between the same 2 points. Look at the initial position of the charge A. Look at the final position of the charge B. ಹಾಗಾದ್ರೆ ಎಲ್ಲಿಂದ ಎಲ್ಲಿ ಮೂವ್ ಆಗ್ತದೆ? A ಇಂದ B ಗೆ. If the initial and final positions are the same, work done in moving the charge does not depend upon the path followed by the charge. Charged particle ಹೇಗನ ಹೋಗ್ಲಿ, path 1 nag hogi, path 2 nag hogi, path 3 nag hogi, work done will be the same. Work done in moving the charge from A to B is 10 10 joules along path 1 andre work done in moving the charge from A to B along path 2 will also be 10 joules. Work done in moving the charge from A to B along path 3 will also be 10 joules. ಅದಕ್ಕೆ ಇಲ್ಲಿ ಬರ್ದಿ ನೋಡಿ, work done in path 1 will be equal to work done in path 2 will be equal to work done in path 3. Work done in moving a charge from one point to another point does not depend upon the path followed by the particle. ನೀವು ಸ್ಟ್ರೇಟ್ ಲೈನ್ ನಾಗನ ತಗೊಂಡೋಗ್ರಿ, ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ನಾಗನ ತಗೊಂಡೋಗ್ರಿ, ಹಾಗನ ತಗೊಂಡೋಗ್ರಿ, ವಾಟ್ zigzag ಪಾತ್ ನಾಗನ ತಗೊಂಡೋಗ್ರಿ, whatever may be the path followed by the particle, if the initial and the final positions are the same, work done will be equal in all the paths. ನೋಡ್ರಿ, ಈ 3 paths ಗೂ initial and final positions are A and B. ಹಾಗಾದ್ರೆ work done in all 3 paths will be the same. Work done in all 3 paths will be the same. Work done in moving charged particle from one position to another position does not depend upon the path followed by the particle. ಹಾಗಾದ್ರೆ ಈ ರೀತಿ ಡಯಾಗ್ರಾಮ್ ಕೊಟ್ಟು ಯಾವ ಪಾತ್ ನ ವರ್ಕ್ ಡನ್ ಜಾಸ್ತಿ ಇದೆ ಅಂತಂದ್ರೆ ಏನಂತ ಹೇಳ್ತೀರಿ? In which path the work done is more? 1, 2, 3, or work done is same in all the paths? Which do you choose? Work done is more along path 1, work done is more along path 2, work done is more along path 3, work done is same in all the paths. Which option do you choose? Work done is the same in all the paths. Work done in moving charge from one point to another point does not depend upon the path followed by the particle. In the forces now, see, we are doing work against electric field, or we are doing work against electric force. ಯಾವ ಫೋರ್ಸಸ್ ಗೆ ಅಗೇನೆಸ್ಟ್ ಆಗಿ ನಾವು ವರ್ಕ್ ಮಾಡಬೇಕಾದ್ರೆ ಆ ವರ್ಕ್ ಪಾತ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಲ್ಲ ಅಂತ ಫೋರ್ಸಸ್ ನಾವು ಕನ್ಸರ್ವೇಟಿವ್ ಫೋರ್ಸಸ್ ಅಂತ ಕರಿತೀವಿ. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೋರ್ಸ್ ಆರ್ ಕೂಲಂಬ್ಸ್ ಫೋರ್ಸ್ ಇಸ್ ಅ ಕನ್ಸರ್ವೇಟಿವ್ ಫೋರ್ಸ್. ವರ್ಕ್ ಡನ್ ಅಗೇನೆಸ್ಟ್ ದಿಸ್ ಕೂಲಂಬ್ಸ್ ಫೋರ್ಸ್ ಡಸ್ ನಾಟ್ ಡಿಪೆಂಡ್ ಅಪಾನ್ ದ ಪಾತ್ ಫಾಲೋಡ್. ಸಚ್ ಫೋರ್ಸಸ್ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ಕನ್ಸರ್ವೇಟಿವ್ ಫೋರ್ಸ್. ಹಾಗಾದ್ರೆ ಹೌ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ವರ್ಕ್ ಡನ್ ಇನ್ ಮೂವಿಂಗ್ ಚಾರ್ಜ್ ಫ್ರಮ್ ಎ ಟು ಬಿ? ಎ ಇಂದ ಬಿ ಗೆ 3 ಪಾತ್ ನ ವರ್ಕ್ ಡನ್ ಸೇಮ್ ಅದೇ ಅಂತ ಹೇಳಿದ್ವಲ್ಲ, ಹಾಗಾದ್ರೆ ಆ ವರ್ಕ್ ಡನ್ ನ ಹೆಂಗ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? ಹೌ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ವರ್ಕ್ ಡನ್ ಟು ಮೂವ್ ಚಾರ್ಜ್ ಕ್ಯೂ ಫ್ರಮ್ ಎ ಟು ಬಿ ಅಂತಂದ್ರೆ we know the formula for calculating work done. Work done can be calculated using the formula potential difference into charge. Work done can be calculated using the formula potential difference into charge. You have carried the charge from point A to point B. You first calculate what is potential at point B. You calculate what is potential at point A. Potential at point B minus potential at point A will be the potential difference between 2 points. Potential difference calculate ಮಾಡಬೇಕಾದ್ರೆ potential at final position minus potential at initial position ಮಾಡಬೇಕು. Potential difference into the charge moved. Charge moved is Q. Work done is potential difference into charge moved. Using this formula, you can calculate the work done in moving the charge from A to B. ನೋಡ್ರಿ, ಈ ವರ್ಕ್ ಡನ್ ನಾಗೆಲ್ಲನ ಪಾತ್ದು ಇಕ್ವೇಶನ್ ಅಥವಾ ಪಾತ್ದು ಯಾವ್ದಾದ್ರು ಟರ್ಮ್ಸ್ ಇನ್ಕ್ಲೂಡ್ ಆಗ್ಯದ? ಡಸ್ ವರ್ಕ್ ಡನ್ ಇಕ್ವೇಶನ್ ಕಂಟೈನ್ ಎನಿ ಟರ್ಮ್ಸ್ ರಿಲೇಟೆಡ್ ಟು ದ ಪಾತ್ ಫಾಲೋಡ್ ಬೈ ದ ಪಾರ್ಟಿಕಲ್? ಡಸ್ ವರ್ಕ್ ಡನ್ ಇಕ್ವೇಶನ್ ಕಂಟೈನ್ ಎನಿ ಟರ್ಮ್ಸ್ ದಟ್ ಆರ್ ಕನೆಕ್ಟೆಡ್ ವಿತ್ ದ ಪಾತ್ ಫಾಲೋಡ್ ಬೈ ದ ಪಾರ್ಟಿಕಲ್? No. ಹಾಗಾದ್ರೆ work done does not depend upon the path followed. Work done just depends upon potential difference between the 2 points and the charge that is moved between those 2 points. ಇದರ ಮೇಲೆ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ನೋಡ್ರಿ. I have given a problem here. See, here is a charge Q. Here is a charge Q. This is a source charge. ಈ charge Q ಏನದಲ್ಲ, it is a source charge. Under this charge is capable of producing electric field around it. This charge is capable of producing electric field around it. There will be electric field all around it. That electric field due to a point charge extends up to infinity. And we have a charge Q naught placed at point A. Point A hatra one charge adu Q naught. The position of point A from the source charge is x comma 0. Andre point A is at a distance x along x axis. The point A coordinates kottbittare x comma 0. There is another point B. on y-axis. There is another point B on y-axis. Its coordinates are given as 0, y. 0, y. Andre is source charge in the point A is at a distance x and point B is at a distance y. Now you are supposed to calculate work done to move the charge to move this charge Q0 from A to B. You have to calculate work done in moving the charge Q0 from A to B. A in the B get test charge Q0 na move ಮಾಡಲಿಕ್ಕೆ ವರ್ಕ್ ಮಾಡಬೇಕಾಗ್ತದೆ. ಎಷ್ಟು ವರ್ಕ್ ಮಾಡ್ತೀರಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ ಅಂತ ಹೇಳ್ತಾರೆ. ವರ್ಕ್ ಮಾಡಬೇಕಾಗ್ತದ ಫಸ್ಟ್ ಆಲೋಚನೆ ಮಾಡ್ರಿ. Will you have to do work in moving the charge Q0 from A to B? Will you have to do work in moving the charge Q0 from A to B? Work ಮಾಡಬೇಕಾಗ್ತದ? First thing, will we have to do work? Yes, because this Q is a source charge. It has produced the electric field around it. So we are moving Q0 from A to B in the electric field. In order to move charge Q0 from one point to another point in the electric field, we have to do work. What is the work done? Work done is equals to potential difference into charge. See, charge is moved from A to B. So you must be knowing what is potential at B, VB. Potential at B is VB. And you must be knowing what is potential at A. Potential at A is VA. Potential difference into charge. What is the charge move? A in the B move madra charge yavadu Q0. Nodri, while calculating work done, you should not take into account the source charge. Illi source charge baribardu. Yav charge na move madirtiralla aa charge baribardu. Potential difference into charge move. Which charge created electric field is not important. Which is the charge that is moved between two charges is important. Yav charge move madirodu Q move madiva. Have we moved Q from A to B? No. Instead we have moved Q0 from A to B. Yav charge move madiva ಅನ್ನೋದು important. ಮತ್ತೆ ಯಾವ ಪಾಯಿಂಟ್ಸ್ ಮಧ್ಯ ಮೂವ್ ಮಾಡಿಲ್ಲ. We have moved the charge from A to B. So in order to calculate work done, we must be knowing potential difference between B and A, VB minus VA into charge moved is Q0. How do you calculate VB? Potential at B due to source charge. We know potential at a point due to a source charge is given by V is equals to 1 by 4 pi epsilon Q by R. So potential at B will be 1 by 4 pi epsilon not Q divided by this distance. Distance between source charge and B is Y. VB is 1 by 4 pi epsilon Q by Y. How do you calculate potential at A due to the source charge? 1 by 4 pi epsilon not Q divided by this distance. The distance is to the X. So VB is 1 by 4 pi epsilon not Q by Y. VA is 1 by 4 pi epsilon not Q by X. VB find out madri. Next you find out VA, substitute the value of VB, substitute the value of VA, substitute the value of charge that has to be moved. ಇವೆಲ್ಲ ಕೊಟ್ಟಿರ್ತಾರೆ. B ಪಾಯಿಂಟ್ ಎಷ್ಟು ದೂರದಾಗದೆ, A ಪಾಯಿಂಟ್ ಎಷ್ಟು ದೂರದಾಗದೆ, ಸೋರ್ಸ್ ಚಾರ್ಜ್ ಎಷ್ಟದೆ ಇದೆಲ್ಲ ಕೊಟ್ಟಿರ್ತಾರೆ. Q will be given, Y will be given, X will be given, Q0 will be given. Will be asked to calculate work done. ಈಗ ಈ ಸ್ಟ್ರೇಟ್ ಪಾತ್ ಮೇಲೆ ಹೋದ್ರೆ suppose the work done is 10 joules. A in the B straight path na ಹೋಗ್ತೀವಿ. Suppose the work done is 10 joules. Suppose if I move from A to B along some zigzag path, if I move from A to B or if I move the charge Q0 from A to B along some zigzag path, can you tell me what will be the work done? Straight path na hodre 10 joules work ಆಯ್ತು. If I take the same charge Q0 from A to B in some zigzag path, can you tell me what will be the work done? What will be the work done? What will be the work done? Work done will be zigzag path ಅಂತಂದ್ರೆ path length increase ಆಗ್ತದಲ್ಲ. If the path is zigzagged, the length of the path increases. ಹಾಗಾದ್ರೆ work done should be more ಅಲ್ಲ. Length of the path has increased, so work done should be more than 10 joules, isn't it? Work done should be more than 10 joules because the length of the path increased. Zigzag nage length of the path increases. No, because work done in moving a charge from one point to another point does not depend upon the path followed. Work done is independent of path followed. Very good. So this is a concept that must be remembered. ಈ ರೀತಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬಹಳ ಸಾರಿ ಬಂದಾವೆ. ಈ ರೀತಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬಹಳ ಸಾರಿ ಬಂದಾವೆ. Right? So is this problem clear? If it is clear, I'll send you a assignment today. Idistu potential, electric potential is over. ಸ್ಕ್ವೇರ್ ಮೇಲೆ ಟ್ರಯಾಂಗಲ್ ಮೇಲೆ ಕ್ಯೂಬ್ ಮೇಲೆ ನಾಳೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾಡಿಸ್ತೀನಿ. ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ವಿಲ್ ಬಿ ಓವರ್. ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಆಟಮ್ಸ್. ಇದಾದ ತಕ್ಷಣ ಪ್ರಾಬಲಿ ಬೈ ಡೇ ಆಫ್ಟರ್ ಟುಮಾರೋ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಆಟಮ್ಸ್. ಆಟಮ್ಸ್ ಮುಗಿಸ್ಕೊಳ್ಳೋಣ. ಕೆಪಾಸಿಟನ್ಸ್ ನೀವು ಕಾಲೇಜಿಗೆ ಬಂದ್ಮೇಲೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀವಿ. ಯಾಕಂದ್ರೆ ಕೆಪಾಸಿಟರ್ಸ್ ನಾಗೆ ಯು ವಿಲ್ ಹ್ಯಾವ್ ಟು ಸಾಲ್ವ್ ಸರ್ಕ್ಯೂಟ್ಸ್. ಸೀರೀಸ್ ಪ್ಯಾರಲಲ್ ಸರ್ಕ್ಯೂಟ್ಸ್ ಬರ್ತವೆ. ದಟ್ ವಿಲ್ ಸಾಲ್ವ್ ಇನ್ ದ ಕಾಲೇಜ್. ಓಕೆ, ಇದ್ರಾಗ ಏನಾದ್ರು ಡೌಟ್ ಅದ? Have any doubts? I think I have solved problems on all possible concepts. ಯಾವ್ಯಾವ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬರ್ತಾವೋ ಅದಿಷ್ಟು ಸಾಲ್ವ್ ಮಾಡಿದ್ವಿ. All different types of problems are solved from potential. I'll send you the assignment today. Try to solve that assignment. And doubt ittanta that we'll discuss. You just text me that question number. ಯಾವ್ದು ನಿಮಗೆ ಬಂದಿಲ್ಲ ಅಸೈನ್ಮೆಂಟ್ ನಾಗ ಅಂತ, that I'll take it up here. Right? Okay, we'll continue in the next class, please.